Yeah, go.
Okay. All right. Thank you for coming. This is like a tradition that every year I give a talk for, in general, nothing fancy, but you know, uh, I love math. There's no secret about it, and I like to give a general talk, not for mathematician or you know. I feel numbers, like all of us grow up with numbers. So the best way to, I mean, in my opinion, of course, I mean, maybe others will disagree, but everything I tell you is my own personal. And I find the best way to give a general talk is to give talk on numbers, because all of us are familiar with that. Okay, here's the question for you. Let's have, I'm gonna draw. And you can move, Murat, like when I move.
Just do you and I'll do me.
Okay. 3, 4, 5. What you are, this is a right triangle. All of us know that, right? What you observe, all sides are what? Integers. Okay, can you quickly, if you took number theory with me, don't talk. Oh, here, thank you. Oh, they bring us some, if you want to help yourself, you don't have to wait till the end. Just come and pick up. As I talk, you can eat. It's fine, if you want. It's up to you, it's your choice. But you are not restricted. Thank you. Okay. So here's a question for you. Can you quickly give me another triangle, write a triangle where all sides integers? One of them is this. And all of us know that a squared, like if you want to call this is A, this is B, this is C. A squared plus B squared, all of us grow up with this formula. I don't think there is one person in this room who has not seen this. This is maybe we learn in 6th grade or 7th grade or whatever. It satisfies this equation. All right, is there a way, and what you observe about the GCD of these numbers, like A, B, C. What GCD, by the way? GCD meaning the greatest common factor between three of them. We have three numbers. There is the greatest common factor between the three numbers is what? 1. That's clear by staring. Okay, is there an easy way to come up with these numbers? Like, anybody want to give me one more except? I'm not going to accept from you or you who were in my number theory. Yeah, but that's what I said. 2 of you, 3. Anybody in this room? I want your participation. Can you give me one like that quickly? Yeah.
I think 1 and 2.
1? It will not work. 1 and 2, okay. This will be what? This will be square root of 5. Right? It's not integer. I want integers, whole number. Yes?
Maybe 6, 8.
6,
6 and 8.
8, but the GCD will be 2. 6, 8, and 10, maybe. Yeah, but 6, 8, and 10. 6, 8, 10. The GCD is 2, not 1. Yeah.
5, 12, 13.
Huh?
5, 12, 13.
Okay, you get it quickly, or you have to do. Okay, here is what I'm gonna tell you. How you come up with these triangles quickly? Like, huh? For me, like. Look, I'm gonna do, quickly, 42. Okay? and then I'm gonna do here 49 minus 9, and here 49 plus 9. Go ahead with your calculator. What is this number? 40, right? Can you check, is it 40 square plus 42 square equal, what is this number, 49 plus 9? 58 square. Go ahead, I need somebody to use a calculator and check if this is true. It is? Wow. Okay, here is another one. 30, 5 square minus 9, 5 square plus 9 on this side. First thing, observe, what is the GCD between the three numbers? 42 and 40 and what? Oh, I need the numbers to be what? GCD, I promised to be 1. So I fail with that. The GCD is what here? 7 and 3.
Yeah, it's wrong. You did the rest is wrong.
Huh?
You did something wrong, yeah.
I don't know what I did.
Maybe choose A and B such that
Relatively prime.
relatively.
Yeah, but relatively prime, I selected 7 and 3.
You didn't do 7.
One has to be even.
7?
A or B has to be even. One of them has
Yeah,
to
one
be
of them has to be myself.
Oh, so that's what went wrong. But anyway, let's remove that condition. Did you still have that? This, yeah. I don't think I need, yeah, one of them has to be even and the other one.
has to be
Oh, okay. All right. So let's have another one then. 24, right? If I remember correctly. Right? And then here 16 minus 9, 16 plus 9. Would that satisfy? Right? Because what is this number here? 7. This number, 25. So can you check 24 square plus 7 square? Does it give you 25 square?
Yes.
Okay, and the GCD between 24 and 7 and 25 is what? 1. Okay. So you're gonna tell me how I do it in general. What are you? I'm not a magician here. We taught that in a number theory course that at least 5 students took that course last semester with me, and we proved that. I did not tell them, just believe me because Ayman Badawi told you so. We have a mathematical proof. But this is how you do it. Look. Choose any two numbers that one of them has to be even and the other odd, and the GCD 1 between them. Like here, what did I select? Here I select 4 and 3. So here is the idea. A is even, B is odd. The greatest common factor between them is 1. All right? And make this here 2AB. This side, which number, it depends which number is bigger, A or B. But we can assume A is bigger. So you do this side A square minus B square, and this side A square plus B square. Then you get the triangle you want, in general. Like here, let me explain how I come up with that. Here, A is a 3, or B, A is 4, and B is what? 3, right? What is the GCD between 4 and 3? 1. Multiply them, 12 times 2, 2AB, 24. Then the bigger 4 square minus 9. And here 4 square plus 9. This method, and this is, by the way, it's unique. We call it a primitive right triangle. Primitive right triangle, when the GCD between all the sides is 1. The GCD. And it's any primitive you construct, you should be able to find A and B, where A even or whatever, one of them is even and the other is odd. Downstairs here will be 2AB, A square minus B square, A square plus B square. It's a complete method of how to construct a primitive right triangle. I'll be honest with you, because you know, what's nice about teaching a course, you learn. I know one direction of them, but we came across a beautiful formula. I think the proof is trivial. I think you remember what's the name? It's a beautiful formula, but the proof is one line, like algebra. Like you just multiply out. So I learned this method when I taught this course. I did not know it before. And this is something maybe students don't know. Like for me, I love to teach a new course. Why? Because not you only learn, I learn too. I never heard of that thing. So that thing was useful to students and to me. When I came through that, and I think I explained that to you, that I never seen that before. But you know, it's beautiful. Is it clear how you do it? So now, okay, let's try. Let's take one even and one odd. I want the student to choose one even and one odd, and to be, the GCD is 1.
5 and 4.
Huh?
5 and 4.
5 and 4. Huh? So, 5 and 4. Multiply it with 2. 5 times 4, 20.
It's 40.
Times 40. And then, 5 is, which is bigger, 5 or 4? You select 5. So you're gonna do 5 squared minus,
4 square.
and here,
Square plus.
try it. Will it satisfy the equation? What is that? 5 squared minus,
9.
huh?
9.
9. And this one,
41.
41.
16, 41. So try 40 squared plus 9 squared. Will it give you 41 squared?
Yes.
Yeah.
Yes, it should. Otherwise, the math will learn. It's baloney, right? If it worked for some example and it does not work for other, why are we doing mathematics then? It become a matter of opinion, right? Okay, is it clear? Okay, I think you gave me an example. What's the example you gave me?
5,
Okay,
12, 13.
okay. 12, 5, 13. I'm gonna ask you, from what you learned from me, what is A and B?
2 and 3.
2 and 3. Yes. Why? Because look, A is 2 and B is what? 3. AB, 6. Multiply with 2, 12. And then this is 3 squared minus 2 squared. And this one is what? 3 squared. Isn't it? Done. Every primitive triangle will be constructed this way. It rely on two numbers, A and B, where the GCD between them is what? 1. Okay. All right, that's the first thing the second one I will talk, and I'm gonna make my talk shrink it. I mean, I'm not gonna make it very long. I'm not sure if you observed the global day. It's like small now. We shrink it. So I'm gonna shrink my talk too. So I will shrink my talk. I'm gonna talk about one more subject today. Okay, this is trivial, but if you talk with me discrete, we always try to show square root of 2 is irrational. First thing, what do you know? What's the definition of irrational?
Cannot be expressed as A.
Yeah, I mean, somebody tell me irrational mean is not rational, which is correct, by the way. But irrational, you cannot write it as an integer over. So this is not equal. If you live your life and the life after, try to write it as A over B, where this is integer, and this is what? Integer not equal 0. Okay? You can sit here, Christine. Okay. So square root of 2 is irrational, means you cannot write it as an integer over, as an integer. Okay, here is a quiz for you before I do. Is pi rational or irrational? Okay, but somebody gonna tell you, well, they taught us in school, this is 22 over 7. This is rational. What you gonna tell them?
This is just approximation.
Approximation, thank you. In fact, this is wrong, the way if you use equal, is wrong. We should write it like approximately, because otherwise we contradict ourselves. 22 over 7 is rational, but we tell them pi equal 22 over 7. That means pi has to be rational. Otherwise, math make no sense. Okay, anyway. All right, and there are many methods to show square root of 2 is a mathematical proof. I have to convince you that this is irrational. And I think you took, Mohammed, you took discrete with me. And you know the method I use. But today you're gonna learn a new method, even much easier, to show how to show this is irrational. Okay, even in discrete math, I never give my student this number. I always give them square. But also this is what? Irrational. I mean, you're gonna use the same proof, but modify. But, okay, so let me tell you how you convince yourself that these numbers are irrational. Okay, here is it. It relies on a beautiful result in algebra. Here is the result. What does it say? If you take monic polynomial, what monic? Monic means, let me explain, let me write it down. Why do we call it monic?
First coefficient.
The leading coefficient here is what? 1. When here 1, we call it monic. Monic. polynomial. Okay? Monic polynomial when the coefficient here is 1. Okay, look what the math tell me. This has integer. And what are these coefficients? an minus 1, an minus 2, keep going, a1, a0 are integers. They are restriction. This integer, a1 integer, okay, has an integer solution if and only if two direction. Anybody want to finish the statement? That's a beautiful result that sometime I teach it in discrete math. Anybody want to finish? If and only if?
The GCDs are 1.
No.
If it's a divisor of k0,
That's the yeah. If and only if has an integer solution, give it a name. Say what? D. So D will be a root of the bulk. If and only if D is a factor of A0. And of course, since you mentioned it, you know the proof. The proof is one line. Because we learned from abstract algebra, if you the integral closure of a GCD domain is the ring itself. Forget what I said. This is like the algebra behind it. Because you know Z inside Q, the integral closure of Z inside Q is Z. So anyway, okay, all right. Let me explain before I tell you anything. Is that monic? Monic or not? Why? 1. If 5 is integer, 2, 1 is integer. If you have a root, an integer root, if you have an integer root, what are the possibilities? So I'm gonna make it equal 0, right? And I'm looking for integer root. What are the possibilities? 1, because look, has an integer solution, call it D, if and only if D is a factor of the constant.
1 and 5.
What are the factors of minus 5? 1, 5, minus 1, minus 5. You try them, right? If none of them work, that means forget it. This will not have integer solution. No integer. No integer solution. Clear? Like if you're looking at this one here, x to the 5 plus 6x plus 2 equals 0. This is monic, degree 5. If you have an integer solution, it should be a factor of what? Of 2. That means 1, 2, or minus 1, minus 2, the integer factors. Because look, minus 1 times minus 2 is 2. So minus 1 is an integer factor. Clear? If you don't know that, you know it now. So this is, that's why I call it sometime. It's a common knowledge. I think this is very nice that we teach that in discrete math maybe, for all students. How to find integer solution for monic polynomial.
So the definition of monic polynomial, the coefficient, they have to be integer too?
No.
The definition, no.
No.
Okay.
It could be, but here.
Yes, yeah, I
Yeah,
understand.
yeah.
That's it.
No, it's just like the definition of monic polynomial over a ring, coefficient from the ring, but the leading is 1.
Yeah, okay.
Yeah. But here the one I need.
Yeah.
Yeah. Okay. Is that clear? Yeah? Okay. By the way, monic is crucial. Why? Because look at this polynomial. Is the coefficient integer? Huh? Maybe I'm. What I want to tell you. It work? Here? Am I confusing myself?
No, you don't have
No, no.
here integer solution.
We don't have. Yeah.
You need the result.
Yeah. Because the leading, with the note I'm telling you, the leading to be 1 is crucial. But this is the. I promise I'm not gonna go deep on things. I'm not saying that I'm going deep, but everything is relative. Anyway. So here is another solution for show square root of 2 is what? Irrational. Okay. I'm gonna show you how you prove x square square root of 2 is irrational. Okay. Let's solve x squared minus 2 equals 0. What are the solutions? X equal what? X equal, right? You agree?
No, we don't. You wrote minus.
Okay. All right. Sorry. Here is what I should change in my statement. Sorry, guys. Not big difference. Not even bigger. Has instead of integer, rational solution. If and only if d is a factor of what? A0. I mean, that every rational solution will be, if you have a rational solution, has
The numerator is
always 1. The denominator is 1.
the numerator is a factor of a0.
Okay.
A0?
No, it has to be like A0, D over B. B will be a factor of the leading coefficient, and this one will be a factor of. Okay, so let me repeat, because I am good in talking on the spot, and sometimes I miss some things, but we are not gonna make big changes. Look what I'm gonna change. AN here. Forget monic. Because I have in mind that my solution is always gonna be integer anyway. So I concentrate on the integer. So, but the only restriction, AN, not 0. I still have the same thing. All these, AN, all of them are what? Integers. Has a rational solution, has, instead of integer, rational solution, CD, if and only if D equal A over B, where A is a factor of A0, B is a factor of the leading coefficient. That's what I need. A is a factor of A0, B is a factor of what? This one here. Has a rational, instead of integer, what? Rational. A rational solution. What rational again? An integer over integer. This is well-known result in algebra. Okay? All right. Okay. Is it clear? Like this, huh? Let's see. So if we have a rational solution, it should be a factor of 5 over what? A factor of 3. So it could be 5 over 1 or 5 over 3 or 1 over 3, because 1 is a factor of 5. 3 is a factor of 3. You agree? You get it? So if you have a rational solution, your solution should be a factor of 5 over a factor of 3. Okay? Okay, now I can show you why x squared minus what? Maybe now you know how to do it. Okay. So square root of 2 is not rational. Let's consider the polynomial x squared minus 2 equals 0. Right? You agree? Okay. So what's that mean? That means we know square root of 2 in particular is a solution. Right? Now assume square root of 2 is what? Rational. That means square root of 2, by the things I gave you, it has to be a factor of what? 2 over 1. So what are the possibilities for the square root of 2? Has to be if square root of 2 is rational, then square root of 2 has to be 2 over 1. According to what I gave you, a factor of 2 over, or what are the other possibilities? 1 over 1, or maybe minus 1. Is it? Is it possible square root of 2 equal 2? Well, if I square both sides, I have 2 equal 4. If this is true, that means 2 equal to 4. Right? Is it? I mean, by staring you do it. You get me? So this is how you convince yourself that the square root of 2 is what? Is not rational. Because if this is rational, it has to be a factor of 2 over a factor of 1. Okay, so now, can you tell me how you convince yourself square root, cubic root of 13, or the fifth? This. Even this is bigger. This is irrational. How you prove it quickly?
X to the 5 minus 13.
Take the polynomial x to the 5 minus 13 equals 0. Then definitely this is a solution. But the math tell me if we assume this is what? Rational. The math tell me if we have a rational solution, it should be a factor of what? Over, for God's sake, by staring. Can you eliminate all of them? I mean, this number cannot be equal to 13. It cannot be equal to 1. It cannot be equal to minus 1. These are the possibilities. Did I miss any? 13 or minus 13 or 1 or minus 1. But by staring, you don't have to do any. This cannot be 13, definitely. Cannot be 1. Done. So you convince yourself that this number has to be what? Irrational. Because the math tell me, and the math here is a free commercial for algebra. This result comes from the algebra, from abstract algebra, from ring theory. This result, field theory, in particular. So, okay. Any question? All right. I think enough. I show you 2 results or 2 things. I'm not gonna talk anymore. Thank you for coming. As I told you, the global, they shrink it. I'm gonna shrink my talk too. So thank you very much. I appreciate your attendance. Yes,
Yes, Ayman, you said something at the beginning about numbers.
I said something beginning about my wife, not
About
numbers.
about numbers. This is another thing. What did you say? You said it's when I look around,
What?
everything is related to numbers. Yeah.
At the beginning?
Yeah.
Yeah.
You said something like that.
No, I said, like for me, I want to give a talk like where I feel like you don't have to be a math major. Anybody will have access to it. And the best way for me is to give a talk about numbers.
And you said everything, in my opinion.
In my opinion.
Yeah.
Maybe somebody will say, well, the best talk is to give a general talk about geometry. So this is what I meant.
I just want to tell you something, so you can add it to your general knowledge. So Al-Khwarizmi said the same thing in the 9th century. He said, when I look around, everything is related to numbers.
Yeah, but that's the
So
thing.
it's not only your opinions.
Oh, okay. Thank you, Sadia. All right. So here's the cheerleader. Okay. In fact, since you mentioned that, there is a famous quote. The quote say, mathematics is the queen of sciences, but number theory is the queen of mathematics. That's by, all of you heard the name, Gauss, the famous Gauss. He said that. Yeah. Any other? I hope you enjoyed the talk. You get something out of it. All right. Thank you, and please help yourself. Go ahead and eat. Thank you.